Hello, welcome back. This is Calculus by Dr. Oz. Today we're going to learn a brand new technique of integration, and it's called integration by parts, and it's applicable to certain integrals. And this is totally different from the U substitution or the basic integration rules that we learned earlier. So this is what makes this topic something from Calculus 2, okay? So integration by parts is all about Calculus 2. And we have the integration by parts formula. You will see the details of that within the video. But I want to make a comment here that in this exercise, part A and part B, we have the ingredients of the integration by parts are provided to you. Okay, we have those all provided to you. Okay, so what I mean by that is like you know what to call U, you know what to call dV, and all you need to do is just to run the process of integration by parts and get done and get done with the result. Okay, so we have two integrals to go. Let's get started. All right, before we start, let me just make you remember this L.I.A.T.E, the acronyms standing for like L to be logarithmic and I to be inverse trig. A means algebraic functions. T means T stands for like trigonometric, and E stands for exponential. So here, if you see functions coming with an order in the integrand, so this rule tells you which one to call U. For example, if you have logarithmic and trig popping in the meantime in the integrand, so then you should go with logarithmic function first to call U, and the rest involving trig, let's say, would be your dV. So going back to the very first problem here and applying L.I.A.T.E here, so I have a polynomial first and exponential next. So going with this with these functions here, I have algebraic, which is polynomial, and exponential. So that means I should call algebraic function to be U for this problem. Just to give you some heads up, because this L.I.A.T.E is very helpful to determine again which function that you are supposed to call for U. And in the second one, for example, you have let me just clean this first. You have 2x plus 1, and you have 2x plus 1 and sine 4x. And in this regard, you have an algebraic function, which is a polynomial, 2x plus 1, and trig. So again, I'm going to call the polynomial, the algebraic function, in other words, 2x plus 1 to be U, and the rest to be dV. Okay, so this could be very helpful. Let me also remind you the integration by parts formula. We have u dv integrated is equal to uv minus v du integrated. So what I'm going to do here is just use this formula together with L.I.A.T.E to make this work. All right. So let's look at this question is nice enough, by the way, to provide you u and dv. So let's look at du to be negative dx, and then I should integrate dv. So you have e to the x over 2, and v is integrated as 2 e to the x over 2. And if you are not comfortable with this integration this fast, you can go ahead and then on a separate place here, you can go ahead and work on the integration e to the x over 2 dx, okay, by calling u to be x over 2, okay, so that you can convert this integral into e to the u du type integral, and you can get the same result that I got here, 2 times e to the x over 2. All right, but anyway, this is side work. This is what we did in the previous section, so that's why I sort of like did that really fast in finding v here. Okay, so let's use the formula, but before doing that, let me just copy this integral here. So I'm going to use u v minus v du, because this is u, and then this is dv in the integration by parts formula. Okay, so integral u dv equals uv minus v du. As you see that at the end, I should take care of one more integral to be integrated. Okay, so let's just write everything down here. U times v, 2 times 7 minus x e to the x over 2 minus v du. Let's see, I have 2 coming in, and then they have negative dx, so that becomes plus 2 v du. Here we go, e to the x over 2 dx. And as you see, you have the same integral popping up here. So the side work, if you had the side work down somewhere, then that side work would be also helpful here. So 2 times 7 minus x e to the x over 2. And obviously this is 4 times e to the x over 2 plus the integrating constant. All right, so this is again something, this part of the question is something that uses our acronyms L.I.A.T.E. This may not be in your lecture notes, but I'm just telling you in the video as a complement, as complementarily. Okay, so you can use this or not, so it's up to you. Okay, so but all I'm saying is that in this problem here, the polynomial is the u in the integration formula, integration by parts formula, and the rest, which is e to the x over 2 dx, is dv. So all we did is just applying the integration by parts formula and taking care of one more integration right here. Okay, so that takes care of part A. And for part B, please move on to the next video. I'll see you in the next video. Bye.